వెల్కమ్ టు తెలుగు వన్ అకాడమీ. మనం జాగ్రఫీ అట్మాస్ఫియర్లో ఈరోజు విల్ సీ వాట్ ఈస్ ఇన్సోలేషన్. వాట్ ఈస్ ఇన్సోలేషన్? ఇట్స్ అ షార్ట్ ఫార్మ్ ఆఫ్ incoming solar radiation. In shortcut, like all the first letters and last wordings have been taken. In short, it is called as insolation. So whatever energy we receive on the earth is only from, actually most of the part is from sun only. So whatever energy or heat we are getting from sun is called insolation. So total energy which reaches the earth surface is called insolation, right? So whatever energy, it's a life of the earth is, sun is the life of the earth. So total insolation received by earth from is only exactly to be say, means if we get 100%, if sun is giving us 100% of insolation, means energy or heat energy whatever, we receive only 0.0005%, cause earth cannot take the whole energy of the sun as it is giving to us. We have to filter it between. So atmosphere does the filtering of the sun rays and it sends whatever needed for the warmth of the earth. If we receive the whole energy, if we take the 100% energy or insolation of the sun, so earth will become a heat ball just like another sun. Or else if we stop all the energy from the sun, means it will become a cold planet. So atmosphere does a judicious thing, like it knows what kind of rays to be sent and what kind of rays to be stopped. Exactly, it acts like a filter. So to be totally, we receive only this much of energy or insolation from the sun. When out of 100%, only we receive only 0.0005%. So in that also you can imagine we are receiving only this much of percent, but also we can see the heat temperatures are going on the earth. Imagine if we receive the whole 100% of insolation, then it's a gone case. So angle of insolation, so how much of amount of energy is received depends upon the many factors. The factors affecting are angle of incidence, length of day and night, and distance from the sun, that is we call as a perihelion and ephelion, and next thickness of the temperature or thickness of the atmosphere on the present day or present time. So there's one band. We say whatever rays we receive from the sun, we can call it in a band or a spectrum of solar spectrum. We can call it as a solar spectrum. Atmosphere of the sun is called as a chromosphere. See, these are the rays we get from the sun. So, this is called solar spectrum or the solar band. So, first is these are like these are classified on the base of the microns, like the in how many microns we receive it from the sun. So, first are X and gamma rays. X and gamma rays, they are really invisible, we can't see them, nearly 0.005 microns, like we are not into microns, but to have an idea, just we'll look into the bandwidth of the solar spectrum. Next are ultraviolet rays. So, what happens to these gamma rays? Imagine like on roads we see traffic signals and traffic police everywhere. If there is any chaos in the traffic, then we'll see traffic constables standing in there and directing the traffic. So, like that only atmosphere works like a traffic, because we don't need all these rays as they come onto the earth. So, X and gamma rays are being of a bit dangerous rays. So, there is a layer in atmosphere, like we have seen in the last classes, there are so many layers of atmosphere in like troposphere, stratosphere, mesosphere and thermosphere and exosphere. In thermosphere only, another layer of another division we call it as ionosphere. Ionosphere. So, these X and gamma rays are trapped in the ionosphere. They'll get trapped in the ionosphere. This X and gamma rays, they get trapped in the ionosphere, as these are very dangerous to our earth. And next come to ultraviolet rays. We know ultraviolet as a very dangerous rays. If we are exposed to ultraviolet rays directly, so we do like any will have some kind of skin diseases, skin cancers and all. So, what is like ozone layer, which is in the stratosphere, nearly from 30 to 50 kilometers from our surface. So, ozone layer will trap these ultraviolet rays, and ozone means O3, and the temperatures increases with the altitude. So, only visible rays for the human being on the earth are like Webb gyre. This is a phenomenon only we can see these rays, because why sun, color of sky is blue? Because as any rays which we receive from sun, they are in short waves. Okay, the insolation, the radiation from terrestrial radiation is in long waves, and solar radiation is in short waves. So, in that also Webb gyre, no, like Webb gyre means everybody knows rainbow, manaki Indradhanushu ela form avutundi. So, Indradhanushulo unde 7 rangulu, these are called Webb gyre. So, violet, indigo, blue, green, yellow, orange and red. In this particularly, red has long wavelength comparatively violet. That's the reason during sunset and sunrise, the sky will be red. Sky will be red because red color is been scattered in the because it having a long wave comparatively violet, so it gets scattered. So we'll get to see red color sky during sunset and sunrise. When come to blue color of the sky, what happens? Everybody knows that in atmosphere we do have moisture and dust. When blue color diffuses, blue color wavelengths are traveling in the atmosphere, all these molecules of moisture and dust absorbs blue color. So, only one logic is whatever we see, the color we see is that is reflected. The colors which we don't see have been absorbed. So, these dust particles and the moisture present in the atmosphere absorbs blue color rays, and that's the reason sky is in blue color. Because of this reason, traffic signals and other things like we use red can be seen from very long distances. That's the reason we use red color for traffic signals or train signals. And next, coming to infrared rays. Infrared also, their micron levels around like 5.500 to something like that. So infrared, these are also dangerous rays. With the naked eye we can't see these infrared rays. And next come heat rays. We can only feel the heat rays, but we cannot see the heat rays. Next come to radio waves. Radio waves are impossible to see with the naked eye. So if there are any particular equipments to see the radio sun is more larger than what we see. The visible sun, what we see is the visible sun, right? But radio sun is more larger and more bigger than the visible sun. So radio waves are used in communication, signals, satellites and all. So what happens to this insolation? We get insolation in solar insolation in these many types of rays, but only what the rays we need and we can see is visible rays, that is our rainbow or Vibgyor, whatever these colors, okay. So what happens after receiving insolation from sun? We have seen like earlier, we receive only 0.0005% only. So what happens to other, in 100%, what happens to other things, right? So when sun releases energy, so it travels to surface of the earth, nearly 1000 kilometers, right? So as we know that there are small dust particles in the sun atmosphere and large dust particles. When large dust particles, they receive these rays, they scatter the rays, they scatter it, they scatter. One of the reason why color of the sky is blue. And next, if the dust particles are big, comparatively small dust, so they'll diffuse the rays. They'll diffuse the rays or insolation from the sun. So in that way, differential topography, differential heating of land and water, so we receive a heat waves. Like land gets heated fast and cooled fast comparatively water bodies. So some part of the solar rays are being absorbed and taken by the water bodies and land. Other things is reflection. When it comes to the snow-capped lands, so these sun rays are reflected back into the atmosphere because that's the concept of albedo. Dini albedo antam anamata. Ante like any lighter particles or lighter material will not absorb sun rays. They reflect it back. So all snow caps, మనకి మంచు పర్వతాలు అన్నీ తెల్లగా ఉంటాయి. డిపెండింగ్ ఆన్ ది ఫ్రెష్ స్నో కూడా ఆ డిగ్రీస్ అంటే ఆ పర్సంటేజ్ మారుతూ ఉంటుంది. బట్ ఎనీ లైటర్ కలర్ సర్ఫేస్ విల్ రిఫ్లెక్ట్ ది సన్ రేస్. సో సన్ రేస్ వచ్చిన తర్వాత మనకి ఇన్ని టైప్స్ ఆఫ్ రేస్లో వస్తుంది. దాంట్లో కూడా ఇన్ దాట్ ఆల్సో దీస్ మెనీ థింగ్స్ విల్ హ్యాపెన్. సో ఇప్పుడు దిస్ ఇస్ ద సోలార్ స్పెక్ట్రమ్ ఆర్ సోలార్ బ్యాండ్. నెక్స్ట్ కమ్ టు what does factors affecting this insolation? I mean, do we get insolation throughout year in the same pattern or same way or in the same places? No, we don't receive insolation throughout the year in the same rays or same volume or same length. It differs from place to place, latitudes, and next length of the day and night. And next, sunspots, they are like, now we'll get into the factors affecting insolation. Factors affecting insolation. There are two factors, extraterrestrial and terrestrial. Extraterrestrial means which are not related to, terrestrial means what? Like anything related to earth or territory. మన భూభాగం మన టెరిటరీకి సంబంధించింది టెరెస్ట్రియల్. ఎక్స్ట్రాటెరెస్ట్రియల్ మీన్స్ విచ్ ఈస్ నాట్ ఫ్రమ్ దిస్ ఎర్త్. సో ఇన్ extraterrestrial and extraterrestrial, anything which is not related to earth, we call it as a extraterrestrial. In this, sunspots, next is meteoritic dust, so we'll come to extraterrestrial. Sunspots. What are the sunspots? Have you heard of any sun flares, sunstorms? అంటే హైడ్రోజన్ హీలియంలోకి కన్వర్ట్ అయ్యేటప్పుడు ఏంటవుతుందంటే లైక్ సన్ లోపల న్యూక్లియర్ ఫ్యూజన్ జరుగుతూ ఉంటుందన్నమాట. న్యూక్లియర్ ఫ్యూజన్ జరుగుతూ ఉంటుంది, ఇన్ విచ్ హైడ్రోజన్ విల్ కన్వర్ట్ ఇన్ టు హీలియం. In that times what happens, no, if extra energy is released in the sun, అంటే it totally related to sun, దాని ఒక atmosphere. Extra energy released sun, it will leads into sun flares or sunstorms. If very low energy released like then required, then a spot called like a blind spot. If this is a sun, somewhere here like some blind spots will form, and these blind spots, when earth they become barriers for the insolation to the earth, means then light will be, insolation rate of the insolation will be less. అప్పుడు మనకి సన్ నుంచి వచ్చిన ఇన్సోలేషన్ తక్కువ ఉంటుంది. అప్పుడు సో దీస్ సన్ స్పాట్స్ ఇవి ఎప్పుడు ఉంటాయంటే అన్ని 365 డేస్లో ఉంటాయా? కాదు. Come around like 11-12 years once. It's a phenomena which happens in once in 11 to 12 years. So we can see that time our insolation will be less. And next come meteoritic dust. Meteoritic dust, when meteors burn, try to reach the earth's surface, they burn in between. Some will reach the like target to reach the target is to reach the earth's surface or earth's atmosphere. So some meteors burn in the atmosphere itself, some meteors burn in space itself, but those try to come into the earth's atmosphere, so but they burn, so they create some kind of dust. When after burning something, what happens, oka kind of dust వస్తుంది కదా, కాలిన తర్వాత ఒక పొగ వస్తుంది కదా, this will, అంటే మన ఎర్త్ పైన ఇది మన అట్మాస్ఫియర్ ఉంటే, సో ఇది సమ్వాట్ హియర్, ఇది ఇక్కడ ఒక డస్ట్ లాగా ఫామ్ అయితే ఇక్కడ నుంచి సన్ రేస్ రావడానికి అడ్డుతుందన్నమాట, అంటే అంత క్లారిటీ ఉండదు. సో మెటీరియోటిక్ డస్ట్ ఈజ్ వన్ ఫ్యాక్టర్ ఎఫెక్టింగ్ ఇన్సులేషన్. నెక్స్ట్ ఈజ్ ఎపిహీలియన్ అండ్ పెరిహీలియన్. What do you mean by ephelion, perihelion? Perihelion means this is earth and this is sun. So what happens now, when earth revolves around sun in its own orbit, in times twice in a year, there are two positions in a year, like in one position it will be near to the sun, the distance from the sun will be less. Once in a year the distance will be more. This happens in June and this happens in Jan, means perihelion. Perihelion means nearer to the sun, means near to sun. Ephelion means far from sun. So these are the two phenomena. In this time also, when it is near to the sun, that happens in January, but logically northern hemisphere will experience winters in January, where earth is near to the sun, right? This is in June. When it is far from sun, northern hemisphere experiences summers. When it is near to the sun, earth is near to the sun, we experience winters. Okay. So this is one phenomena where sun rays, like insolation will be less. This phenomena is like we can see in another classes, because as the earth rotates from west to east, so we know the axial tilt of earth is 23.5 degrees. So because of that reason, in spite of near to the sun, also we experience northern hemisphere experiences winters. But in spite of far from the sun, like ephelion, northern in that is in June, northern hemisphere experiences winter because of the axial tilt. So even insolation rates also differs with the ephelion and perihelion. Now these are the extraterrestrial. Extraterrestrial means which are not related to the earth, the factors which are not connected to the earth. Now terrestrial. In terrestrial we see we can see fog and dust, volcanic dust and moisture. So what happens now? If there is so much of humidity of fog in the atmosphere, it especially happens in winters, like so atmosphere becomes thick, బాగా గట్టిగా అంటే దాని మనకి క్లారిటీ ఉండదు అనమాట, ట్రాన్స్పరెన్సీ ఉండదు. సో అందువల్ల ఏంటవుతుంది, ఇన్సులేషన్ ఎర్త్ని రిసీవ్ చేసే లోపల అట్మాస్ఫియర్ దాన్ని డిస్పర్స్ చేయడము, తర్వాత డిఫ్యూజ్ చేయడం, స్కాటర్ చేయడమో చేస్తుంది బికాస్ ఆఫ్ ది థిక్నెస్ ఆఫ్ ది అట్మాస్ఫియర్. అండ్ వాల్కనిక్ డస్ట్ ఇట్ హ్యాపెన్స్. సో జపాన్లోని సమ్ 60s ఎప్పుడో జపాన్లోని ఒక వాల్కనిక్ ఎరప్షన్ అయింది. దాట్ వాల్కనిక్ ఎరప్షన్, లైక్ ఇట్ వాజ్ సో బిగ్ వాల్కనిక్ ఎరప్షన్, బికాస్ ఆఫ్ దాట్ US got, like they experienced winters in July itself. Winters means we have to get it in December, right? కానీ వింటర్స్ వాళ్ళు జూలైలోనే వచ్చేసింది బికాస్ ఆఫ్ ఈ వాల్కనిక్ డస్ట్ వల్ల. ఎందుకంటే ఆ డస్ట్ అట్మాస్ఫియర్లో అంత థిక్గా ఏర్పడిపోయి ఇన్కమింగ్ రేడియేషన్ని అవి ఆపేసాయి. ఎంత జూలైలో ఎంత రేడియేషన్ రావాలో అంత రానియకుండా అంత ఆపేయడం వల్ల, అంత థిక్ డస్ట్ వల్ల. So volcanic dust. Next is moisture. We know that if there is any moisture or humid in the atmosphere, so penetration of the solar radiation will be difficult. Next is how do we use this solar radiation, insolation? Like there are many ways, ante solar cookers, solar winds, solar energy, tarvata now we use even greenhouses for agriculture. So we use solar radiation in, mankind uses solar radiation in different ways. Yeah, inkokati angle of incidence. Extraterrestrial ne angle of incidence. Angle of incidence means so this is a equator, a 0 degrees. From north 23.5 degrees are Tropic of Cancer, and 23.5 degrees south from equator is called as Tropic of Capricorn. What happens now? Sun's rays are vertical only in the tropics. They are oblique, slant in poles. So only tropics will receive the direct sun rays, mean vertical sun rays just hitting directly on the tropics. So but poles will experience vertical or oblique, and that is also the distance is very far from the sun. So what happens now? These tropics receive more insolation. Tropics will receive more insolation. That's the reason these are the warm climates of the earth. Warm temperatures or warm climates we do have near the tropicals. Angle of incidence means, imagine, keep a paper here, just have a small, like we'll see. So this angle will be exactly 90 degrees, right? Insert a paper here. This angle will not be 90 degrees. So this is called angle of incidence. Angle of sun rays. The rays which are vertically hitting the earth are called angle of incidence or angle of sun rays, where 90 degrees will form a 90 degrees angle. So we have seen like solar radiation. Earth receives insolation from three ways. One is solar radiation. In that we have seen nuclear reaction, like fusion and fusion, nuclear fission and nuclear fission, hydrogen, conversion of hydrogen into helium, and next in the form of electromagnetic radiation. Other Earth gets energy or radiation or apart from sun, will get it from endogenic forces. Endogeny means internal forces. Ante mana bhumilo unna forces which are internal to the earth. These are plate tectonics, volcanism, earthquakes, etc. So everybody knows that mantle and core of the earth is very hot, still it is hot. So what are the heat energy we receive from the internal structure of the earth? These are called endogenic forces. For that example, plate tectonics, volcanism, we know what happens when there are volcanoes. So all the magma comes out in the form of lava. And next is earthquakes. Even earthquakes are caused due to the heat energy. And another factor is gravity. So gravity, because of gravity, we pull some source of energy. Gravity releases some source of energy. So because of its own gravity, earth develops a kind of energy. So apart from solar radiation, like earth receives energy from three sources, from endogenic forces from itself and gravity of the own earth. What happens to, like, what are the effects of insolation? So earth, after getting heated by insolation, it passes to the lower layers of the atmosphere. What happens now? If earth gets heated, so it has to maintain itself. Even our body also, as a human being, if we also maintain like our heat balance, if we get too much of heat, we release it in the form of sweat pores, so that body gets regulated and cooled. Every body has a own mechanism. If you from like human being to the earth. So after earth gets heated very much from these three factors of radiations, insolations, so what it does now, it gets heated very much, means it will release the energy in the form of terrestrial radiation to the lower layers of the atmosphere. So when the two different bodies with different temperatures come in contact or exchange their energy, so if one body is in a warm condition, one is a cold body, what happens when these two bodies come in contact? This is warm current, this is cold one. So they come in contact, they try to exchange their energies. This warm try to give its warmth to the cold body and cold one to the warm one. In this process what happens? Either this becomes warm or this becomes cold. Till that they will not get divided, or if there is any break in between, then only these bodies will separate. This exchange will continue till they attain the same temperature or contact is broken. This is called conduction. This process is called conduction. So this is conduction. When Earth releases its terrestrial radiation, so top layers of the atmosphere will feel the conduction. And because of conduction, what the next thing will happen is convection. Heating and cooling of convection, vertical heating. Convection means this is horizontal heating, this is vertical heating. Phenomena done in the layer of troposphere. And radiation. The heat received by Earth makes Earth hot and it releases the heat. That is called terrestrial radiation. Next, atmospheric circulation. What is atmospheric circulation? I mean, we can feel the wind, but we can't see that, right? So it is the movement of air in the atmosphere. We know like air moves in many directions, up, down, right and left, right? Atmospheric circulation is explained by two laws. One is Coriolis law and one is Weis-Ballot law. So atmospheric circulation means the movement of air in the atmosphere, the movement of air in the atmosphere. So these are explained by Coriolis law and Weis-Ballot law. So Coriolis law, what is Coriolis law? Whatever the object that moves freely all over the globe, so imagine if air is moving from here, it is trying to move like this. So, but because of this Coriolis law, Coriolis force, it takes a curve. I mean, it cannot travel directly from here to here, but it will take a curve, or like it could be right or left, whatever the direction, it will takes a curve slightly from its starting point. Because of the rotation of the Earth along its axis, the winds are deflected. As Earth rotates from west to east, so this is a air stream. Imagine this is the air stream. It has started from here. As it is near to the atmosphere of the Earth, when the Earth rotates, this air stream will also take a curve like this. This movement is called atmospheric circulation. This happens because of the tilted axis of Earth and rotation of the Earth. In the northern hemisphere, this curve is right. See, if an wind have started from here, if it has started from here, when the Earth rotates, this curve will be towards its right. In southern hemisphere, it will be towards its left. So in northern hemisphere, this curve is to the right. In the southern hemisphere, left from the original path, in the which way it has started. So this Coriolis law means the wind or the air which has started from its original path, it will get depleted, or it will take a curve from its original or initial path because of the tilted axis of the Earth and the rotation of the Earth. That happens like in northern hemisphere, from original position to it will take right. In southern hemisphere, from original position to it will take left. So now that is Coriolis law or Coriolis force that makes the winds move. So Bayes-Ballot law, the movement of air mass from high pressure to low pressure. Everybody knows that air is attracted from high pressure to low pressure. If there is any low pressure here, if there is any high pressure here, if some air is trapped in between, it will directly attract it to the low pressure areas. So, movement of air mass means any block of air, particular block of air. From high pressure to low pressure is wind. So, wind is what? A block of air which travels from high pressure to low pressure. So, if you stand with your back to the wind in the north hemisphere, in this phenomena what happens? No, if you are in the northern hemisphere, so imagine wind is coming from this way. So, turn your back towards here. Air pressure is lower on your left hand than right hand. So, what happens in northern hemisphere? You can feel pressure on the right hand, not on the left hand. Same vice versa in the southern hemisphere. If wind is coming from, okay, I'll tell example. Wind is coming from this direction. I am standing like this. So, I can imagine, I can feel the wind hitting on my right hand rather than my left hand. But I am in southern hemisphere, I am in Australia. Then what happens? Same reversal will happen. I can feel the wind on my right side than my left side. Sorry, higher pressure on left in southern hemisphere means higher pressure on left, in northern hemisphere means higher pressure on right. This is like Bayes-Ballot law. The winds are strong where the isobars are crowded and weak where they are wide. So, isobars means on a cartographic map or on a weather map, if we draw lines of the same weather, then these are called isobars. Lines joining places of equal atmosphere. So, we can say this is our planet Earth. If we join weathers with the same atmosphere, like I am joining all the places with 20 degrees. So, these are called isobars. The imaginary lines drawn on the places with same weather. So, they can be like this also. So, we can see pressure in the places where isobars are crowded. If a place is having isobars very thick or crowded, means near by near. Another place is having isobars are very far away. So, in this region you can feel high pressures. Pressure will be high, atmospheric pressure will be high. In these regions, atmospheric pressure will be low because of gaps or widens between the isobars. So, winds are strong where the isobar crowded and weak where they are wide, obviously. Along and near the earth's surface, wind does not move freely in a horizontal plane. Terrain influences the direction. Near the earth's surface means the top layer of the earth. This is the earth, like ఇది మన టోపోగ్రఫీ అనుకుందాం. సో ఇక్కడ ఏంటవుతుందంటే విండ్స్ ఒక హారిజాంటల్ ప్లేన్లో నడవు బికాస్ ఆఫ్ డిఫరెంట్ టైప్స్ ఆఫ్ రిలీఫ్. ఈ టెరెన్ వల్ల ఏంటవుతుంది, విండ్స్ ఇక్కడ కొండ ఉందనుకోండి ఏమవుతుంది, ఇట్ విల్ ఫ్లై అప్ it will come down to the valleys, it will travel like this, again it will go up, it will again come down. So, winds cannot and does not move freely near the earth's surface because of its terrain. అదే కొంచెం అప్పర్ అట్మాస్ఫియర్కి వెళ్తే winds will flow freely because no barriers. There are no barriers. అది కొంచెం హైవే లాగా యాక్ట్ చేస్తుంది అనమాట. హైవే మీద స్పీడ్గా వెహికల్స్ వెళ్తాయి. అదే సిటీ లోపల ప్రతి చోట బ్రేక్లు వేసుకుంటూ వెళ్ళాలి. సో అంత ఫ్రీగా వెళ్ళే ఫాస్ట్గా వెళ్ళలేం. దట్ ఈస్ వన్ ఆఫ్ ది రీజన్. ఈ winds కూడా దే ఆర్ నేమ్డ్ అకార్డింగ్ టు డైరెక్షన్ దే కమ్ ఫ్రమ్. If a wind is coming from east to west, then that is called as easterlies. Suppose a wind is coming from, it has origin or it has started from west to east, then it is called as westerlies. There are many types of winds like trade winds, easterlies, westerlies, polar winds. There are so many winds. Hope you like the class. If any doubts, please do comment in the comment section. Thank you.